Yeah, good morning. Let us resume our discussion. So what were we discussing in the last class? A couple of points. Can any of you tell? What is
we were we were discussing about classification. We discussed about nearest neighbor classifier and k nearest neighbor classifier. Then we went on discussing about unsupervised classification, which we can call clustering. And in that clustering, we learned about k-means clustering, which is basically nearest neighbor clustering sort of thing, and the iterative process followed. And then we were talking about how to apply these two methods in bag of words approach.
Right, very good. Okay. So we before that we have discussed about bag of visual words very briefly, and we in that we have seen that we need clustering to be done. So we will see now exactly where it need to be done. So in that clustering is needed. So we have got the details about basic supervised and unsupervised classification and clustering. And now let us see in the context of bag of visual words, how do we apply clustering, or what is bag of visual words? In what kind of features does it give? Okay, so let's resume our discussion on bag of visual words. As we discussed, so the first step is in bag of visual words is get the training samples. So what we wish to do is, using the training samples, can we effectively make a feature representation? Okay, and then that can it be used for applying on the test samples? That's the basic idea. And we want to leverage from the shift features or any features which are reasonably advanced features, descriptors, in describing at different key points or at all the regions of the image. So we will see through slides that there are different ways in which the features can be collected from an image. So if you are given a whole image like this, okay, we can take features for each patch to represent the image. We can also take only at the feature points, okay, to represent the image. Okay, the features to represent the image. And there are different even other ways. Okay, so you can take pyramidal features. Okay, not only at one resolution, you can take the features at say lower resolution, coarser resolution, and then finer resolution, and so on, and stack them. So there are different ways of collecting the features, but in either way, the idea of bag of visual words is what? So we will come back to the step-by-step procedure, but let's revise once on the basic idea of bag of visual words. What if there is an image? How do we want to represent an image? That's the basic idea. More than that, how do we want to represent a class of images? Can any of you give an idea? What are the essential idea here by which we can represent a class of images? We want to represent a class of images. Let these class of images be, say, in some case, it is medical images. And then we have other class of images. This, let it be, say, persons. Okay, and or faces or whatever. So images related with persons. Okay, and then there are other class of images related with, say, natural objects, vehicles, for example. Okay, so like that. So now what is the basic idea of bag of visual words? Can any of you tell? Based on the discussion that we had in the last classes. Okay, did you remember anything about how does bag of visual words help us to represent the class of images?
The bag of visual words take features from a particular class, and
right.
And then we take the image, and then we capture all its features, and then we correlate with all the features of different classes. Like each class has some specific sort of features. So
Yeah.
if features of our image match with one of the classes, so we say that it belongs to that class.
Right. As the name bag of visual words represents, we first wish to see for visual words. Okay, or code words. So from visual words to code words we will go. I will give the terminology or the what we meant by these things. See, visual words means what? You have several regions in any of the images. In each class of images, you have several regions. Okay, we may have several. So around each, if we consider a patch, what is this? This is nothing but a visual word. Okay, like that, if we consider a specific class of images, we will have specific some kind of visual words. So if I see medical images, assume that this is the medical, say, blood cell images. Okay, so there what we can see, there may be a parasite. Okay, there may be, say, red patches. Okay, and then say some nucleus or whatever. So different kind of visual words we will have in medical images. Similarly, in persons, you may have legs, okay, hands, and then head. And so on, right? And then in vehicles, you may have actually wheels, okay, handles, okay, and then parts of the car and so on. And so on. Okay, so now what will happen? If we see overall, there is a specific visual words which will occur more frequently in one class of the images. Now, from visual words, what we wish to get is code words. Okay, code words means what? So, see, this whole class can be represented with some of the very frequently occurring visual words. Okay, so all medical images, these medical images, the visual words of importance are, say, parasite location, as we discussed, all these things, parasite location, and then red blood, red regions. Okay, and so on. These may be of importance in terms of medical images. Now we can see in a given image how much of this count is there. Usually, if this is a medical image, what will happen? This count of number of patches having this kind of, okay, patches, red patches and blue patches. White blood cells are shown in blue color because of the stain. So blue patches will be much more. Okay, so if this is medical image, so this implies that this is a medical image. Whereas if we would like to, if we take any person's images, what will dominate? These are also the visual words which we try to see how much frequency do they have. This is parasite location. Okay, so assume that visual word 1, 2, visual word 3. Okay, so we take the same visual words again, even here, because we don't know in test case which is the image. We also have V4, V5, V6. Assume that V6 up to V6 or V7 corresponds to persons. So these are corresponds to, say, leg and hand, okay, and head, okay, and then probably shoulder and so on. Okay, so we will see that if it is a person image, you can see that the person images, the frequency of these occurring, these kind of visual words occurring will be high. This implies that this is a person image. Right now, if you consider a different kind of images, which are, say, for example, vehicle images, then what will happen? Up to V1, V2, V3, V4, V5, V6, V7, all these are there. Okay, but the frequency, if you see, for these, they will not be high. Frequency for V8, V9, V10 may be high, which may be, say, for example, wheels, handles, okay, and then car parts or whatever. and so on. So anyway, you can consider this. This implies this is a vehicle. I hope you got the point. How we essentially use the bag of visual words. In this, where are we using shift descriptor? Where is the shift descriptor? Or where is the any image descriptor that we are using? Oh, have you understood what?
The formation of this histogram.
Yeah.
Frequency histogram.
Can you remember? Can you tell again?
Sir, in the formation of these histograms, frequency histograms that we see.
Yeah, histogram is not this histogram, right? Histogram is say count. Here actually, if I see a test image, and in a test image, I see that 100 patches will have this. Okay, and then say 1,500 patches are has this, and then white blood cells probably I think so 80 patches has this. This is the number of patches I am writing here. Where is the shift descriptor involved here?
Identification of the visual words.
Right. So visual words itself are represented by the shift descriptor. So whatever you see here is a vector. It is a, say it can be HOZ or shift. Okay, descriptor is what I am representing visual word as. Because image patch I can't simply carry, right? I have to represent in terms of this. Say if this is 8x1, for example, this is 8x1 HOZ or shift descriptor. Now, with respect to this, I need to tell whether it is a patch corresponding to this like parasite or red cell, red patch or blue patch, leg, hand, okay, shoulder, and then wheels, handles, and then probably front, say for example, whatever mirror, assume that mirror. Okay, so if I need to tell, say these are the 10 visual words, if we consider, if among these 10 visual words, which is this visual word? I need to check. Okay, so now the question is, this is in general the method of bag of visual words. We want to go in a supervised classification manner. Okay, so how do we want, what are things that are needed now? How do we approach? Where do we start and how do we approach? That's the question. So let us start. I will give some background. So assume that we have samples from S1 to S1000. Samples meaning the images. Okay, S1 to S1000. Given all these images, okay, now we can use this as training samples corresponding to 3 classes. Assume that these are the 3 classes. Okay, so now we were also given test samples S1 to S100 to classify into 3 classes through bag of visual words. What is the first step? First step is you find out the key points in all the 1000 images. At each key point, you find out the shift descriptor. Okay, so you may have how many, say in each of them, you may have 5 key points or 100 key points and so on. So how many shift descriptor you may have? 1000 here, 1000 images. Okay, into assume that each of them has, okay, 20 key points, just to have a some better picture of what we are doing. 20,000 visual words we have now. Okay. And we want to deal it as a supervised classification problem. We are given a test patches S1 to S100. This is a test patch. Okay. And I want to put into one of the category. Now tell me, how should I proceed? Yeah. What do you think? What is the next step? Any of you can wish to attempt? What is the next step here? You have all the shift features now. So the first step is to extract all shift visual. These are all the visual words, as you can see here. Okay, these are all the visual words we have now. Then what is the next step? We need to have representatives for the class 1, class 2, class 3, right? How do we get that? How do you think we will get that? Any idea?
So classification.
Okay, classification I have to do, fine. See, assume that I will divide these visual words into class 1 visual words, class 2 visual words, and class 3 visual words to make the discussion better. So we have class 1. How many visual words? Let's assume that we have actually out of these 1000. So as we discussed, say 3300 are first class, assume that. And then second class is 400 and third class is 300, just to make our numbers easy. And then if we go proportionately, we have actually 300 into 20, so 600, 6,000. Okay, visual words. Okay, for class 1, here how many? 8,000 visual words. Okay, for class 2. And then class 3, we have again 6,000 visual words. Here are where we are from the first step, after the first step. Now, what do you think is second step? In second step, what we need to get, I will tell. What we need is need code words or representative visual words for each class. Okay, I wish to get assume that. Okay, so from these 6,000 visual words, assume that I wish to get probably 60 visual words here. Sorry, 60 code words here. Okay, and then here I want to get 80 code words and here also 60 code words. Overall, how many representative code words I will get, or representative visual words or code words I get? It will be 140 plus 80 to 220. Yeah, 220 visual code words I will get. Okay, so now what should I do? Okay, from here to here. In step 2, what is that we should do? Any idea? I need some good answer now. See, here you have actually in person class, if you consider, okay, so you will have actually hands, not only hands, head and so on. Even on head, you may have hundreds of images. Okay, even on head, what you may have? Hundreds of key points. Okay, even on hands, you may have hundreds of key points. On the leg also, you may have more key points. So do you think all will form the code words? That's how we got actually 20 key points for each image. Okay, and then for each image, there are several images as well. So now how do you think I will get 80 from this 8,000? Again, 6,000 to 60. Okay, 6,000 to 60 code words. And how should be these code words? Yeah, I need some answer. Rajesh?
To select the best key points from the 8,000 key points.
Right. So how do I decide which are best? We need to decide which are best, right? So we should at least have descriptively characterizing the best. So if I tell that some student is best in the class, okay, will you people agree? Won't ask any question or what? Of course, if I tell you your name, then you may agree. Yeah, what is the descriptor for best? You know or doesn't know?
I think that key point should be unique for each image.
Okay. Any other students? Siddhartha? Okay, Saket? What is best key pointer? How do I get from 80 to 8,000 to 80? Bhavya? Okay, so anyone, if anyone knows, you can tell. You can tell your views. There is no answer for it. In fact,
Like, sir, if we choose some corner points or we do some template matching with respect to one like head, then also we can get some specific features out of this 6,000 words.
okay. See, I will give you a better idea. Assume that I have 100 images. Say I just take some snapshots where the persons are there. Okay. And I want to represent a single person. See, every day in 100 images, assume that legs might occurred for 1,000 times. I need to represent all 1,000 times legs in the code words?
No,
Hmm?
no, sir.
No. In key points, all will come because in each image, leg is anyway gives a key point. Similarly, hand will give a key point, shoulder will give a key point, head will give a key point, eyes will give a key point, nose gives key point in each image. And there are 1,000 of persons and 1,000 into those many key points, 20 I may get. 8,000 I have got. So do you think I have to represent each of them 1,000 times?
No, just one representative.
Yeah,
for-
one representation of leg is enough. One representation or a couple of representations of leg is enough. Couple of representations of like other parts of the person is good enough to represent a person. But I need legs differently from hands. Okay, so they have to be distinct among them, and they should not be same as correlated with other key points. Okay, so they should span also the class of objects in sense that say if a person class wise has to be there. Okay, so it has to span, and then the legs, some of the features of legs and hands, etc. has to be there. Head has to be there. Is it not? They have to span the object overall. Okay, the key points, and then they should be distinct from each other. Now, how do you think I can get such key points? Say if I sketch all these key points, okay, for persons, assume that is it easy to understand for persons. See, if I see some features, only 2 features I just have seen, okay, for each key point, and then all, say if I see some key points are like this, okay, so I have seen all 8,000 here, okay, so key points looks like this. What can you imagine? All these key points may correspond to what? May probably to leg, and all may correspond to hand, and all these may correspond to eyes, all these may correspond to shoulders or head. Is it not? The key points of different persons of the same part will be together. Okay, but different parts will be different. Is it not? Now, I need some representative key points of these. How do I get? That's the question. Assume that we have now 4 things. Okay.
We should take the mean value of that particular part of.
Okay. Should I take mean value, or is there any better method? I just know the key points now. I don't know even the mean. Means I can't separate shoulders from eyes. I can't separate key points of legs from hands and other things. I just have the pool of key points with me. What should I do to get the representative key points? In fact, these are all the visual words. Okay, visual words represented with how many features? With 2 features. Okay, here we represented. We can also represent in higher dimensions. 2, we need code words. Okay, how do I get? That's the question. What should I do to get actually say I need 4 things, right? So mean you said mu1, mu2, mu3, mu4, but I don't know separately all these the different groups. What should I do? What should I do? I think you should be able to tell.
First, we must cluster them.
That's
Cluster them together.
what else we do. We know clustering, we will cluster them because they're all of, say, we don't know the class labels or group, they are not divided. in groups, even though we visualize them like that. Okay, so they're all key points, just chunk of key points, 8,000 key points. Okay, 8,000 visual words. To what we need is actually 80 code words. Okay, so how do we get? By clustering. What method do we use for clustering here? We can use simply k-means clustering. Any method of clustering you can use. Since k-means clustering is simple, apply k-means clustering to get actually visual code words from visual words, from bag of visual words. Okay, you have a lot of visual words, from that you get the code words. Okay, so and now I have the representatives for each class like that. See, should I consider all say 3 class samples together and cluster, or should I cluster each class samples differently? What should I do?
Cluster each class sample
Different. Okay. See, if I do each class sample differently, I'm getting assumed like that. If I put all samples also together, what do you think will happen? What is the problem I may face? So assume that these are all the class 1 samples. Okay, and then the class 2 samples also has visual words somewhere here. Okay, class 2, I know labels because I know this is a supervised classification problem. I know the labels. I'm sketching anyway with different color. Okay, also different format now I'm doing. Okay, and then the third class, put dots. Okay, right. So even now, if I cluster also, I will get the code words, right? So V1, okay, V2 and so on, V3, V4, whatever. Okay, V5, V6, V7 up to V10. So this I can put together all the samples and then cluster also. However, if I take the corresponding class labels, class samples and cluster, it may be simpler, little simpler to get the corresponding code words. Okay. But however, since usually yeah, ask her.
In this, how will you know like which class
I
descriptor?
need not know. Oh, fine. I need to know it because see, then what I will do is one way is we get the code words differently for each class, then form the bag of say visual words V1, okay, and then to V10. Okay, so first these might have come from class 1, these from class 2 and class 3. Okay, and then I see the frequency. Okay, frequency of visual words. Okay, or code words. I see V1 to V10. Okay, for test image.
So I didn't get it. Like
Test image means for the
I didn't get it, sir. Like if I'm a little bit confused. Like how do I know that V1 to
yeah,
V4
I will tell.
class 1?
Yeah. So one way is if we do visual, if we get the visual words to code words separately for each class, you know a priori itself. Okay, these
Yes, sir.
class 1, these correspond to class 2, these correspond to class 3. Okay, that is the case 1. In the other case, what we do is we can get the visual words together. Okay, but we will have actually training samples, right? So anyway, let's go to that step. Second step is just to get the apply k-means clustering. Through k-means clustering, get the code words or representative visual words. Okay, so this is the second step. See, third step, what we can do? There are as 2 ways as we discussed. If we know a priori which corresponds to which class, okay, we can use them directly, and then for a test image, you take the visual words, okay, and then put the count the class frequency. Okay, Based on that, you say that if the class frequency for these visual words is more, it belongs to class 1. This belongs to, if class frequency for this is more, it belongs to class 2 and class 3. Okay, like that you can divide. That is one. That is the step 3. The other way of doing it is, see, you assume that you have clustered all of them together and got V1 to V10 in this case. Okay. So now what we do, we have V1, V2 up to V10. Here still we don't know which belongs to class 1, which belongs to class 2 and so on. Okay. Now what we have is, we have but the training samples for class 1, which are 300 samples. And then class 2 training samples, which are 400 samples. And then class 3 training samples, which are again 300 samples. What we do is, with class 1 training samples, we just try to see the class frequency. Okay, so for each of them, you just see how many, say V1, V2, V3. If V1 to V3 are corresponding to class 1 visual words mainly, then what will happen? They will have the high frequency. Is it not? And remaining will have a low frequency. Okay. So for all the 300 samples in the training data set, this is training bag of visual words vector. Okay. Training bag of visual word feature vector. You understand now? From the shift features, I have constructed bag of visual words feature. How am I constructing? I first got the code words, and then I calculated the class frequency for all 300 samples. So now how many I get? 300 training samples. Okay, for class 1. Similarly, here I will get 300 or 400 bag of visual words. Okay, features per class 2. Here I don't know whether, say, which corresponds to V1, V2, V3, it corresponds to class 1, class 2. I need not know also. But these training samples will say that, okay, will guide me in appropriately assigning the test samples to the correct class. Okay, then here also I will have actually 300 bag of visual words, okay, features per class 3. Now this is the training procedure. So I have constructed bag of visual words features for each of the samples in the training data set. Now step 3, step 4 in this case is, okay, take test sample. What do we do from the test sample? Extract what from test sample? Visual words. That means you take actually the locations of key points in the test sample. For each key point, you take the patch. For each patch, you take the shift descriptor or whatever, or HOG descriptor and so on. With all this, we get the extract the visual words. These may be of dimension, say 200 cross 1 or whatever. Okay, depends upon the number of visual words I get. It may be 50 cross 1 also. Okay. Now what I do for these visual words, I will try to see. So I construct with this V1 to V10 again, V1 to V10. I construct again a histogram. Okay, so we have constructed a histogram. Okay, so this is again, this is what are we calling? Bag of visual word vector for test sample. Right? So this is of what dimension? 10 cross 1. Each of the bag of visual words feature vectors in class 1, class 2, class 3, they are also 10 cross 1. How many such things total? Okay, we have actually 300 for class 1, 400 for class 2, okay, and then 300 for class 3. Now what I do? I apply like a conventional classification procedure and try to see whether this 10 cross 1 test vector is close to this 300 cross 300 samples bag of visual words vector of class 1 or 400 bag of visual words of class 2, and then 300 bag of visual words, okay, of class 3. Okay, I apply a supervised classification procedure. Step 4, if you 5, if you would like to consider, apply supervised classification. Supervised means I can apply whatever, neural networks, nearest neighbor, Bayesian classification, or any other classification. Classification, but with which features? With bag of visual words features. In assigning test sample to class 1, class 2, or class 3, based on the respective class of visual, bag of visual features. Is this clear? Is this clear or not? Okay, I think.
Sir.
Yeah. So if there is no response, I assume it is clear. Okay, fine. So now let us see some of the slides to understand this better. So these are the slides from Professor Ifros, Cargan Mellon University. So these are very well described slides. So I am directly leveraging from that. So you can see, say what we mean by bag of visual words is this. So we are representing each image by a set of visual words. How do we get these visual words? The procedure wise, how do we get these visual words? We first get the key points. So we may get key points at different locations. Okay, and use those key points to get the visual words, whatever. So we get at several locations and get the key points. And this is done for each of the patch in each of the images. And we get several patches describing the visual words. For each of these things, what do we have? We have a feature vector. Okay, of 8x1, if we consider, okay, 8 bins in HOG. Let it be HOG feature vector or shift feature vector or several other feature vectors. Okay, so this itself we are considering as visual word now. Visual word is not a visual like, so there is a visual patch with which we have extracted a vector, and that we are calling it as word because the terminology has come from the natural language processing, where the words were initially put into bags. Okay, so as we discussed, this is the analogy. So if we consider the medical terms, you have, these are the words which frequently will come. So if you want to classify the document into medical or economic document, what I do, I just count the, say if I consider this to this, so there are 15 words, assume that. So I have a 15, 1 to 15, okay, word 1 to word 15, okay, and I wish to see which word to put into one of the category. Okay, so if some words which doesn't fit into any category, I can leave them because they're not very important. Okay, so whichever words can be put into some of the categories, I will, which are close to these visual words, I will put. And then I can see that the frequency will be much higher. If it is an economic document, then the frequency will be much higher for these visual words. If it is a medical document, the frequency will be higher for this kind of visual words. Okay, this is the this kind of words. Okay, this is the analogy that we are using. These are words, and what we are seeing is visual words. That's only the difference. So now if you have 3 different classes, you can see that the visual words can come from each of these classes. So overall, you see that from this you get 2 visual words. Assume that from this you get 1 visual word, and from this if you get 1 visual word, you have 4 visual words. Put together is the bag of visual word vector that we construct based on the frequency of occurrence of the patches corresponding to those visual words. Okay, as you can see here, this very clearly depicts that. So person image will have the high frequency for the person patches. Okay, whereas the bicycle image will have high frequency for this bicycle class of images. And then this kind of class of images will have high frequency for this. Now, how does the learning happen? We first take the several visual words. Okay, in fact, we first take the visual words and then code words representing these visual words in a compact way or a small set. These are all considered as code words. You can consider these as code words. And these are all the visual words. Okay, so code word dictionary means we take the, for each class, some code words will be there. Putting together what we get is the code word dictionary. Okay, and use them for classification, because we can see that for a particular class, which code words has to be most frequently occurring. If we don't know which code words from which class, then what we do? For training samples, we know what is the bag of visual word. And then test samples also we know what is bag of visual words. We see the similarity of this test sample bag of visual words with the training samples bag of visual words. And whichever is the most similar to that class, we will assign this test sample. So no need to know, in fact, which visual word has come from which class as well. So that's what is described in a more detail now in subsequent slides. Okay, so feature detection can be done in different ways. So as we discussed before, see some kind of HOR features when we want to extract. That means face, eyes being darker than the forehead and the nose region. What we have seen is a kind of features looking for this. And this we have seen across the whole image in a sliding window manner. That means at each location we see and then see where this kind of patch more agrees with respect to the information in the image. Okay, so that's first approach for extracting the features. And then the second approach is to find out at a regular grid. So for each patch, we extract some features. Say histogram features if we extract, then we can have each patch also some histogram features. We can also have histogram or even histogram of orientation gradients features. For each patch. The other way of extracting features is we have only at the key points. In each of the case, what we are trying to represent? We are trying to represent the image as a set of features. Okay, so image may be represented as, say, in this case, if we only consider the feature points or key points, okay, then we may have actually 200, okay, 200 feature vectors. If we consider at each region, say if this is 100 cross 100 image, okay, so you are considering 10 cross 10 patches, okay, to represent a feature vector, then how many we will have? Oh, so this side 10, this side 10, okay, and then 100. Only 100, is it? So 10, 10, right? So let's take 1000 cross 1000 image just to give a better picture. Okay, so 1000 cross 1000 image, if you have 10 power 4, okay, feature vectors. What are all these feature vectors doing? These are all representing image. Representing an image. Okay, and then if I consider sliding window, there also it is same. Okay, we may not consider all features. Later we have the methods of pruning in sense that we consider only the significant features. That also can be there. Essentially, what we don't want to do is take any way of representing an image by features and then represent them. That's all. Those are the features that we use for as visual words. So you may have actually, if we apply only HOR features and so on, you may come up with say 500 features by sliding window and then selection, feature selection. Okay, so both put together, these are the visual words. This is the procedure to get the visual words. So you can apply, there are plenty of methods in the literature. We can consider any of them, which we discussed, or scale invariant feature transform by David Lowy, and then the Viola-Jones method by Viola and Jones for face detection. So their features we have discussed. Okay, so interest points, as we discussed, in fact, it starts from David Lowy. After that, the other things, these are all the slight extensions of that. Okay, representing in a better way rather than a rectangular patch can we go for and so on. Elliptical patch and so on. As we have seen here, all those different ways, even random sampling is also considered. Instead of taking at all regular grid locations, can we go with the random sampling? Whatever may be, finally get the representations in terms of visual words or in terms of these are also referred to as key points. Anyway, at key points, we are getting visual words and text tones. And to get the code words, what do we do next? What we do is we apply k-means clustering. Some kind of clustering. From the what we do, we can get the lesser number of visual words, okay, representing the class of images. Okay, not just single image. Before we were having the single image representation. Now we have class of images. So as we discussed, shift descriptor is very widely used. So it can also be used. So and it gives the different locations in the image, as you can see. Okay, for in each image you get this. Okay, and then these are different representations of the same idea. Okay, and you have for each patch you construct a dictionary. Dictionary means what? Like all class 1, class 2, class 3 code words put together is called dictionary. In the sense that if you give any image, we want to see whether which is like the visual words here or which location in the dictionary, and then want to assign a appropriate identity to this. Okay, and this test image, these visual words and test image. So this is what you can see. Each of these will give different points here. And you can apply k-means clustering kind of clustering, okay, to separate. This is also referred to as vector quantization. Those who know a little bit of scalar quantization very well. Okay, so what we do in scalar quantization, we just say 2.5 or whatever, 2.1, 2.2. All these we bring it to, say, for example, 2. Okay, and then if we apply round operation, okay, we can bring the other things into to integer. Okay, non-integer to integer we do, right? So by using a rounding operation or whatever. This is scalar quantization. Essentially what we are saying, if we have hundreds of samples, okay, thousands and lakhs of samples, we can't represent all the discrete levels of the samples. We just want to capture, say, if the range is from 1 to 100, we just want to capture in terms of 100 different levels or 100 different discrete are distinguishable numbers or distinguishable quantities. So that's how we are applying scalar quantization. In the similarly, this is vector quantization, because the whole of these vectors, all these are vectors in 2 dimensions, we represent by a single vector. Okay, that's why it is called vector quantization. We are representing the whole lot of our cluster of vectors by a single centroid of the vector, for example. That is vector quantization. Okay, and then clustered image patches, if you see, they will be like this and they represent good details of different classes. And then what we do, we take it as sample and then find the, see where to which code words they match better, and then accordingly assign it to the class label. That's all. You can see that these are all vehicles class, okay, and so on. So this is how actually we get the frequencies, and based on the which frequencies are higher, in the training samples to which it is closer, the bag of visual word vector of the test sample, we will assign the corresponding label. So this was initially demonstrated for several natural image based classification. In fact, image classification is a very big problem in the sense that you have wide variety of classes, ranging from, say, classifying a different class of images like beach, mountain, forest, and city, and so on. This is a very high level classification. After that, within the city, is it a building, car, and so on, road? Okay, even within the indoor regions, is it a sofa, bulb, and so on, person, and so on. So many things are there. We have very large number of classes. And hence the problem is very like high dimension, in sense that you can see usually it's intractable, one can say. We cannot even uncountable number of classes we have. And then we should have a very elegant procedure to do that. So this is the bag of visual words. If you have any question, you can ask. Otherwise, there is one question. So what are we missing in this bag of visual word representation? Can anyone point out? Say when we are representing a person by a bag of visual words, or when we are representing a car by bag of visual words, what is that is missing? Can any of you attempt? What is that is missing when we represent in this way? This is a very elegant procedure, not only for classification, but also for tracking. Okay, and then many other, say, panoramic creation and so. Panoramic creation you can do by shift itself, but tracking also can be done through with bag of visual words. So any patch you take, and then for different class of patches you take, construct the bag of visual words. Okay, and then you try to see similarity with which visual words it is more for a particular class. Based on that, you say whether it is same or not, or which class it is. So what are we missing in this bag of visual word representation? You can see here in the last slide. Okay, so there seems to be no geometry. True or false? No geometry means what? You are not considering a head and leg, head at the top and leg at the bottom. So each visual word is they're mixed up. You don't have the spatial information. Okay, but still it works because it represents the class very effectively. Okay, and then it doesn't matter. The leg has to be there and head has to be there, or either of them has to be there to say it is a person with more confidence. Okay, and then the other things also you can ponder upon. Okay, how much is the dimension of patch we should consider? Okay, what is the sampling scheme in the sense that how do we take the visual words? Okay, how much dimension should we consider for getting the feature representation? Okay, what kind of feature should we consider? Okay, are they shape-based features or invariant features more? Okay, so all such things you can do that. Fine, we will conclude here. If you have any question, you can ask. Okay, thank you then. So in the next class, we will discuss on this image segmentation, and then subsequently we will discuss on the stereo and move on to the deep learning topics. Yeah, thank you.